GitHub is the world's leading platform for building software together. A place where ideas become real through collaboration, transparency, and the power of version control. For developers and DevOps engineers, GitHub is far more than just a code host. It's the backbone of modern workflows, bringing together repositories, branching, reviews, automation, and security into one seamless ecosystem. So whether you're contributing to open source or shipping enterprise applications or automating delivery pipelines, GitHub gives you the tools to work faster, smarter, and work as a team. In this course, you'll discover why GitHub has become the essential hub for today's development lifecycle, and how mastering it can transform the way you build, ship, and innovate. My name is Peter de Tender, a lead technical trainer here at Microsoft since summer 2019. Originally from Belgium, and managed to relocate to the Microsoft headquarters in Redmond, Washington 4 years ago. My training portfolio initially covered most of Azure, with a focus on Azure architecting and Azure DevOps. Over the last 18 months, this heavily transitioned to our Azure AI and, as you can see, GitHub courses. Outside of work, I still like to share knowledge with technical communities through technical writing or speaking at conferences. And when I'm distracting myself from technology, it usually means baking something in my home kitchen or exploring the Pacific Northwest in my walking shoes. If you should have any questions on anything throughout this course, don't hesitate to reach me by email or ping me on Teams, petender@microsoft.com, or connect through LinkedIn at linkedin.com/in/PDTIT. Although the course is titled GitHub Foundations, you'll see that we're actually going to cover quite a lot. The first part is focused on version or source control using Git, after which I'll shift more to source control with GitHub and sharing some additional details on GitHub product plans. Next, we'll dedicate some time clarifying the concepts of open source and inner source projects, as well as how GitHub embraces Markdown syntax for most of its repository communication and documentation. And then from there, we got 4 more topics to tackle, starting with GitHub projects, allowing you to not only manage your code repos, but really add that DevOps project methodology to manage your team. And then next, I'll introduce GitHub Code Spaces, offering a Visual Studio code-based development environment running in the browser. We can't talk about developing or DevOps without skipping the security complexity. So that's where the next module will cover GitHub security best practices. And then we're going to close all this using generative AI-based development with GitHub Copilot. Now, while I hope this video course content will help you understand the different GitHub capabilities from a foundational perspective, know that you can continue your own learning at your own pace and in your own time using our Microsoft Learn platform. The baseline content used for these videos is split up in 2 parts, reachable from the following URLs, aka.ms/learn GH-900, Part 1 and Part 2. There's a total of 16 modules across Part 1 and Part 2, which I got consolidated into 9 individual videos. You know what? Let me open my browser and walk you through the learning path for a minute. So when you follow any of the 2 links, Learn GH-900, Part 1 or Part 2, it's going to redirect to our larger Learn platform, where we're inside the training space, the learning path for obviously GitHub Foundations. And as you can see again, we got Part 1 and then over here Part 2, but it's basically based on the same concept. So what's the idea? Again, in your own time, whenever you want, you can scroll down and you're going to find that set of modules. Where then the modules, it means like it's a more dedicated space out of the presentation, but also remember that not each module has a dedicated video because we try to consolidate some of those modules. So from here, you would basically go through the index or the outline, what's there in each and every module, So when I start with, for example, what is version control? The idea is here to read through, and it's obviously a lot identical to the snippets in the presentation, but I think there's a lot more material that you can read through than what I use to present from. And then every now and then, if I take a step back, you can see that in some of these modules, we also have those exercises. So when you open up one of those exercise placeholders, you're going to see that down here, it's going to tell you to start the exercise on GitHub. So what that means is you could open it up. I'm just going to open a new tab because otherwise I lose my Learn page. And the idea is that you're going to start going through this exercise from GitHub. So you need a GitHub account, preferably a personal account, because it might interrupt with maybe company policies that you have in your GitHub Enterprise environment. And then from here, you copy the exercise. And the way it works actually pretty cool is that you're going to clone the repo, which might be a little bit challenging for the first 1 or 2 modules because we didn't really talk about cloning yet, right? But then from there should be pretty intuitive how to use it. And every now and then you need to wait like 20 seconds, 30 seconds. So there's a little agent running in the background that's going to validate if you actually complete all those tasks successfully. And then for closing each and every module, let me take one step back. You also have module assessment, and that means that you're going to get a few sample questions to just reflect, like, do I actually understand the main topic of this module? Now, I have to be honest here that these questions are not exactly the ones showing up on the exam. But it should help you, like, do I really have a good understanding of this topic? If not, nothing wrong. You can go back, read through, learn, go through the exercise once more, and then probably from there you can go through those knowledge checks quite successfully. So that's the little take on what our Learn platform specifically for GH-900 has to offer. Another way to validate your skills on GitHub Foundations is taking the GitHub certification exam. This certification is intended for individuals like yourself who want to validate your understanding of foundational topics, GitHub products, as well as concepts of collaborating, contributing, and overall working on GitHub. The certification is valid for 2 years. More information on what to study for and how to schedule the exam can be found at this link, aka.ms/learn-GH-900 Let me show you quickly what information you can find on that certification page. So if you follow that AKMS Learn GH900 Cert link, it's going to redirect you to the GitHub Foundations certification page. So again, a lot of information here, and just wanted to clarify for just a minute. So it's highlighting like what's the expected level since it's foundations, pretty obvious it's for a beginner. What kind of role where during the presentation later on you'll hear me talking about developers, DevOps engineers, but GitHub allows you like to use it for a lot of different roles to store your code and everything else. Then if we move down a little bit, obviously, if you want to take the certification, it all means that you need to be ready to pass that exam. So that's where, again, the 2 links are showing up here for part 1, part 2, as I just explained a couple of minutes back. And then from there, you can go through even more practice assessments. So when you select a practice assessment here, it's going to give you a set of, again, additional 50 questions in this case, but it might vary a little bit. So before I talked about the knowledge check at the end of each and every module, giving you 3 sample questions typically. Now these questions are still different. So obviously the main idea is to just go through as many questions as possible. Also keeping in mind that these reference questions are not the same ones on the actual live exam. But it's going to help you getting a good idea like, am I ready for that exam, yes or no? And then once you think you're ready, you're going to take the exam, you're going to read through like what are all the objectives. I would say, first of all, try to go through all videos that we have in this series because it's really going to help you. Read through all learned material, go through all the exercises, and then from there, go through all the assessment questions. And then you're ready for the exam. And that means at some point, you're going to schedule the exam. So Microsoft is working together with third-party exam center called Pearson VUE, which means that you can see here in my US dollar currency, it's $99. It might be different in your local currency. And every now and then there are like discounts, but I have no real idea how that works because it's depending on certain programs, maybe locations. But just look at it that every now and then the cost might be lower than that. And then for getting even more ready to be able to pass that exam, we also offer you a study guide. So the study guide is not like a manual. It's not a go-to resource, I would say, to really pick up knowledge or move up your skills. But it's really about what do I need to study? And it's basically a collection of a lot of URLs in the Learn platform out of that part 1, part 2. But there's also a lot of links to the actual product documentation. So just wanted to share this pretty short, pretty quick, but to give you some like kickstart to just feel more comfortable once you are ready to take that exam. So that's all I wanted to share in this little section. With all that out of the way, welcome to this first module on understanding the importance of source control or version control using Git. Version control is a foundational concept in modern collaboration and software development, and this module introduces the idea in a simple, approachable way. Git isn't just a tool for software developers. It's a collaboration system that benefits anyone working on files that evolve over time. So whether a team is writing code, creating documentation, or developing complex content together, Git helps keep everything organized and trackable. Version control is all about understanding how work is changing, knowing who updated what, and how different contributions start fitting together. By the end of this module, you will have a clear picture of what version control is, why distributed systems like Git are so powerful, and also how Git and GitHub play different roles in the development lifecycle. Now, what is version control? Version control is like a smart organizational assistant for your projects, as it keeps track of every change made, who made it, and when it happened. Instead of overriding old work and maybe losing progress, a version control system maintains a complete history of your files over time. This makes it easy to compare updates, understand how a project evolved, and recover earlier versions whenever needed. It's essentially a safety net that gives teams the freedom to experiment without the fear of breaking something important. One of the biggest advantages of a VCS is how it supports parallel work. Teams can create branches, which are separate workspaces where new ideas, features, or even fixes can be developed independently. When the work is ready, branches can be merged back into the main project, keeping everything organized and conflict-free. Developers can also tag specific versions to mark milestones like releases, making it easier to again track major updates. Altogether, version control keeps collaboration smooth, structured, and efficient, whether you're working on code, documentation, or any project that changes over time. Git itself is built on the idea of distributed version control, which means every person working on a project has their own complete copy of the repository. So instead of relying on a single central source, each user carries the entire project history with them. This makes Git incredibly powerful. Work continues even without an internet connection. Changes can be made safely, and the overall system becomes far more resilient. When developers eventually reconnect, Git efficiently synchronizes and merges all the contributions, ensuring everyone stays aligned without losing any important work. Now, what makes Git stand out is how well it scales and supports collaboration. It handles projects of all sizes with ease, from small scripts to massive enterprise code bases, while managing all those changes quickly and reliably. Git tracks updates in a structured way, helping teams understand exactly what was modified and why. This creates that smooth workflow where many contributors can work in parallel, experimenting freely using branches and merging their work with confidence. The result is a development process that's faster, safer, and a lot more organized. So really making Git a cornerstone of modern teamwork. Now, a Git repository might seem mysterious at first, but it's really just a well-organized collection of everything your project needs to track its history. At the heart of Git is the working tree. Technically, actual files and folders you interact with during development. And then alongside it sits the repository itself, stored in a hidden .git directory. This folder contains all the magic. Every commit, every branch, every tag, every piece of metadata Git uses to understand how your project has changed over time. Git also relies on unique hashes, long strings of characters that act like a digital fingerprint, to precisely identify every version of every file, ensuring that nothing ever gets lost or confused. And then inside the repo, Git organizes information using 4 main types of objects. A blob representing a file content. The tree representing the directory. A commit captures a snapshot of your entire project at any point in time. And then forward, a tag labeling important commits, like, for example, a release. Branches build on this by linking commits together under a recognizable name, most commonly main or master. Beyond these structures, a typical project folder also includes familiar directories, like, for example, src for source, tests, and doc, as well as files like the .gitignore to tell Git what files to skip, and then also the README markdown file to introduce the project. Working with Git follows a somewhat simple, repeatable workflow that helps developers and DevOps engineers to really stay organized and in control of the work. It all begins by creating or maybe cloning a repository. For example, use Git init. This sets up a brand new project, while Git clone downloads an existing one so you can work on it locally. Once you're inside the project, branching becomes your best friend. Comments like git branch and git checkout let you spin up isolated environments where you can experiment, build features, or fix issues without affecting that main project. And then from there, everyday work becomes a smooth rhythm of editing files, staging changes, and then committing snapshots. Use stage updates with git add filename or git add dot, which means if you want to include everything you've modified. Then when the changes are ready, git commit and a descriptive message saves them with a clear description. Git also supports merging, like through git merge, making it easy to bring work from different branches together. And then finally, collaboration happens through pushing and pulling. So git push origin sends your changes to that shared remote repository, while git pull fetches and integrates updates from others. So this brings me to the main question. Are Git and GitHub the same thing? Well, while they are closely related, they play very different roles. Git is basically the tool, a local version control system that runs on your computer and tracks changes to your files over time. It works primarily through command line operations like git add, git commit, allowing you to create branches, save snapshots, and manage your project history. What I actually didn't clarify yet is that Git was created already in 2005 by Linus Torvalds. Yes, it's the same person behind the Linux operating system. So it's literally 20-year-old technology were running for the latest and most complex enterprise application development lifecycle scenarios we still see today. GitHub, on the other hand, is the platform built around Git. So instead of storing your repositories only on your local machine, GitHub hosts them in the cloud. And yes, there is also GitHub Enterprise Server that you can run in your on-premises scenarios, making it easy to share your work, collaborate with teammates, and contribute to open source projects. With features like issues, pull requests, reviews, and powerful integration, such as GitHub Actions for CI/CD pipelines, GitHub adds a rich collaboration layer on top of Git's core capabilities. Launched in 2008 and now part of the Microsoft family for quite some years already, GitHub makes your projects accessible through a web interface or applications like GitHub Desktop, enabling teams to work together from anywhere in the world. So now you have an introduction level understanding what Git can do. Let's switch to my demo environment, where I'm going to show you how to get started with the configuration settings in Git first, followed by building a little cat website application. Because who doesn't like cats, right? And from there, showing you how several Git commands will assist in this application development process. Now, talking about demos, remember that we have the Learn Platform modules, where I showed you that several of those have exercises integrated. While my demos are showing similar tasks, know that the exercises are different, actually leaving enough challenge for you to discover if you go through them. And the repos I use for several of my demos are publicly available, so feel free to clone them as examples. So this demo is all about using Git on your local machine. So I wanted to start with showing you the actual official Git source control management tooling website, because that's where you find all official documentation. It's also where you find additional tools, like based on what Git can do, but then having like a partnership with some other companies who are really leveraging the capabilities of the Git tooling, and then obviously also installing the tool on your local machine. I already have it installed, but I wanted to point that out, that it's obviously available for all different platforms. So I'm going to use it on my Windows machine, but since it's command line, it means that it's basically the same look and feel, the same experience if you're running it on a macOS or on Linux. Even in like a Cloud Shell in Azure, AWS, you have Git available, and probably on other platforms that I'm not really using myself. So from here, you could download, or what I like to use is the winget, like command line install tool for the Windows platform. And then from there, we can start using it. So if I do git version, always good to check like what's the version. There's automatic update if you allow it through the initial install. That's important. So I'm running the latest version 2.52, which means like, wait a minute, you talked about the fact that it's 20 years old. How can this just be version 2 point something? Well, it's mainly in like that second number, but not too important. Just make sure that you try to have the most recent version. From there, we can do git config list, and that's going to show me a set of parameters. And I'll highlight a little bit because I can imagine sometimes it's a little bit weird to see that there's a lot of text on the screen. So you can see here a lot of different things about how Git is recognizing your environment. One of the steps that we probably configure is username and user email. So what that means when we talk about Git operations, like later on Git commit and a few other steps that I'll walk you through in different parts of different demos, you want to highlight who's the author of the changes. And that's typically where the username will be used, and preferably your email. So to define that configuration, although it's already defined in my environment, right, you would run git to obviously call the tooling. You would type in git config using -- and then from there, global, which means we're going to use this for all Git interaction. Now, you don't always have to use global. You could do local as well. And that means it's valid for a specific session. And then you would do username, and obviously providing your username, like in my case, Peter the Tender, pretty obvious. Or you would do the same for your user.email, providing your email address. I can imagine that you're wondering, like, okay, but how do I know which commands to use, like pretty much any other command line tool? And that's where you can or go back to the website I showed you, git-scm.com. Or another interesting one here is if you type in git help, followed by the actual command you want to run, like since I talked about adding parameters, defining the configuration, we can do git help config. And then from there, it's going to open up a web page, and it's basically running from your local machine. So that's, I would say, really beneficial, because every now and then you might not have direct internet connection. Maybe you cannot really connect to the documentation page, right? And that's where this is pulled up from your local machine, thanks to installing Git. And like all documentation on how to use Git, I opened up the specifics for config, but it's available for any other. So if we do git commit, you can do the help, git help commit, git help, anything else. That's the main thing. So from here, we can actually move on with using Git and actually doing something with it. So I'm going to clear my screen. And as I told you, I'm going to create a little web application for a cat website. So I'm going to create a new folder, and let's call this the demo cats. And then going to move into that folder. We just have an empty folder. So there's nothing really in there yet. So the first step we need to take is initializing the resource part of the folder, identifying it as a repository. So I'm going to run git init, and that means initialize this folder to become that repository. And since we talked about branches, we're going to identify that this is the initial branch, and you can give it a name like I mentioned. Typically, we call it main. It used to be called master, but it wasn't considered inclusive. And that's where technically you don't even have to call it main. So you can actually come up with any other name, but main seems to be the concept where it's considered your go-to production repo at some point in time. So I'm going to call this main. And then from there, we're going to tell Git like, hey, I want you to use this branch using the git checkout, and then -b, like connect to this branch. And obviously the branch is called main. Now, when I do git status, it's going to show me that I'm on the main branch over here. No commits happened because in the end, we just activated it as a repo. And then there is nothing to commit because, again, we didn't make any changes yet. So what I can do here is creating a new file. I'm going to use Notepad to do that. The good old Notepad, although I guess we might need to use something else. So I'm going to open up my Notepad. And I'm going to add a header here. So I could say hello cats. And then closing for a little bit of HTML that I still remember. And then from here, I could do git status again. Well, now it's sort of starting to work a little bit because it shows me like, well, I don't recognize any commits yet, but I can see that there is a file that appeared, got created, right, in this folder, and it's untracked for the moment. So it knows about the file, but it doesn't really track the changes yet. So what we're going to do here is git add, and what we can do is adding an individual file. Now, to make it a little bit easier, I could already do git add dot, and that means that any new file that I'm creating or changing, deleting, adding, and so on, will be recognized. So I'm going to do git add dot, and then when I do git status, you can now see that my index file is getting traced. So this is now really Git watching over what's going to happen. Now, technically, I created the file, I added some text into it, where now it means I need to tell Git, like, I'm happy with the changes, and I'm going to commit those changes. So I'm going to use git commit. I'm going to add -m, like adding a little message, comment message to it. And what we did here is create header information. For now, it's telling me, I'll make it a little bit bigger. You can see that it's picking up the message. It's tracking one file, the file got changed, and there is insertion, which means we're adding more code into it. I could also do git log, and that's going to show me slightly the same experience, but it's showing me the full commit message. Now, this is a pretty long number, and you'll see later on that it's typically only looking at like the first 4, 6, 8 characters. And you can start interacting with your commits later on by just using that number. But at the same time, since we defined the username and email, that's what you see in the author settings, and it's also keeping track of the time in like universal time. Now from here, we can make some more changes. So I go back to my little web page, and I can do something like, welcome to my demo cats website, and then maybe adding a little paragraph. This is my placeholder for cat pictures. I save my changes. I go back into Git status, and now you can see that it's again keeping track of all those changes. Now, obviously, I'm using Notepad, which probably is not the best editor, but it works fine for this part of the demo. But what if we now shift to, for example, Visual Studio Code? So I'm going to switch to my VS Code using command line. I can just do code, and that's going to open up this file in my VS Code. From here, I can open up my file. I can see all the changes that I made, and I can make more changes. I'm going to make this easy because it's not about the website, obviously. I'm just going to add some more changes. Well, now what's going to happen is that inside VS Code, because it's running on the same machine as where my Git is running, we now have this source control integration. So out of this source control, basically everything that I showed you up till now in command line Git interaction is now showing up in that little version control, source control blade. So what that means is that it's keeping track of all the changes. And the nice thing is that I can select the file, and it's going to show me the differences between the starting point of the file and where I'm currently at. Like keeping track of all those changes instead of like running Git status continuously, you can now use a more visual representation of your changes. Which also means if I go back to my file and I'm going to make some more changes, like I'm going to delete all this, I'm going to save it again. In my source control view, it's now going to change as well. So pretty easy, pretty obvious, I guess, to just look into it. Now from here, I didn't commit my changes yet. So what that means is I go in here, I select my file, and I'm going to commit like a state change. Now, you can define settings in the backend of VS Code that every change in source control is almost immediately accepted. Now, what I did here is like a two-step process. I call it my Peter safety net. And what that means is that I need to manually check in my files, similar to what we did on the command line, right? So now I checked in, like it's okay, I approve all the changes, and I'm going to commit, and then you're going to see that it's not allowing me to commit because it tells me here, please enter a commit message. So that's what I need to add here, where I could do clean, remove my warning message, clean up HTML, because we removed, we added, and from here, we basically have all the changes. If you're wondering how this looks like on the command line, I can do git diff, and it's going to show me the differences. Now, in this case, because I already committed, it's not going to change a lot. But from here, we can continue adding files, updating files, anything like that. So I started with that git add dot for one file, but technically it's recognizing all files, which now means if I go back to my editor, I'm going to add a new file. I'm going to call this the, pictures.html. And we're going to call this later on picture placeholder. Or what if I add a new folder for CSS, because maybe at some point in time we want to make this a little bit more like graphical appealing. And then inside my CSS, I'm going to create a index.css file. All those changes are still appearing in source control. For now, it's going to show me you made a new file, like an update right over here. You created a new folder, where now it's a little bit confusing, and that's obviously what I want to highlight. You have your index CSS, and then a little bit further here, you can see that it got created in that CSS file and folder location. So now I can do the same. Let's say I'm happy with my index CSS, but I don't want to check in my pictures because I still want to update code. I now have that flexibility that I don't need to check in all the changes in all the files and folders. And then again, from here, I'll move to my commit, provide a commit message. And from here, we're basically repeating the same process, where now if I go back here and I do once more git status, you can now see that we have the same feedback. We checked in the file because I clicked that plus button, and yes, I still need to provide the commit message. And there is a change in the picture file, but I did not check in that file. Then to nicely close everything, I'm just gonna confirm, added more CSS styling, and from here, I'm committing. You might wonder like, hey, Peter, what's that publish branch doing? Well, that's a little integration for the next module, and that's where out of VS Code, we're gonna build the bridge into like GitHub, but we're not there yet. So hold on for a little bit, I would say. One last task we can talk through is what happens if I delete files. So I'm gonna switch back to my terminal. So what if we made changes, and I'm gonna break my web application, because again, it's not about the website as such, right? But imagine I delete my file. I'm on my command line, so I'll make this a little bit bigger, and I can run delete index file. When I check my status of the folder, I still have my pictures, HTML, got my CSS folder, and yes, my index web page is gone. If I check in Git, so we do again Git checkout for that index file, you're going to see that there is no feedback. For now, if I do Git rm index file, it's now flagging it as like, hey, wait a minute, the physical file was gone, but Git didn't really know that yet, like it was not confirmed. So it's like a two-step process where now I need to confirm again, and I'm going to do Git checkout once more. And now you can see that it tells me like, hey, wait a minute, I had this file in my index, but I can no longer see it. But what if we now want to recover that file? That's where we use git reset. So I'm going to do git reset. Head points to the baseline main version that we had before in the branch. It's flagging unstaged, and it's having, make it a little bit bigger for a second. It's flagging the file here with a capital D, and that means I recognize this file got deleted at some point in time. For now, we can do git checkout once more, and still nothing really visible. For now, if I go back to my VS Code, you're going to see that now, although the file got deleted, and I didn't switch to VS Code, but I showed you on the terminal that the file was literally gone, we now perform the full restore. So in short, I'll recap. We created the file, we made some changes, then eventually adding more files, adding the CSS folder, checking them in continuously, like going back and forth. That's mainly the operations we're doing. And then simulating one of these scenarios where you might delete a file from like the physical file perspective. You need to inform Git that you're actually okay in deleting the file. And then from there, using the git checkout, git reset, opening the file, and it's like fully restoring the file. The same operation obviously happens from within VS Code. I'm going to delete the file from here. I go to source control. You can see that it's not immediately picking it up. So there are a few different ways, and that's where sometimes I know like colleagues and obviously our customers, some of them like working with command line. I have to be honest, I really like that VS Code integration because we're technically still doing the same thing. So whether you like command line, maybe if I need to switch from like, let's say Windows into another platform, I know I can rely on my Git command line skills, even if it's not using VS Code as a development environment. I think that's pretty much everything I wanted to show. I got two last little steps that I can show you, and that's pulling up. So let's first do a commit, because we again had some last changes. So I updated the code after the restore. It told me nothing to commit because we did the same from the VS Code step. Well, now I can do git log, and it's going to show me all the different commits that happened over the course of my little demo, right? So you can still pull up the full history. We started with step number 1. We had the creation of the repo. So we create that head and then calling the repo main. We made some changes, creating the HTML cleanup, then adding more CSS styling and all other operations. Well, now we could fine tune this because obviously this is only 3 examples in like 2 minutes. But technically, you could have a lot of history in your production-ready repos, where now you could do like, well, give me the logging, but I don't want to see everything. So you can use the -n or the -n, and that's going to pull up the latest operation or any other. So there's, again, a lot of really powerful tooling inside Git. It takes you some time to play with it, to really experiment with it, I would say. And then know that the alternative is having that integration in your development environment where I'm using VS Code to show you briefly what it was all about. I think that's pretty much it, what I wanted to show you. So with that, let's go back to the presentation. So with that, let's recap the core concepts learned throughout this first module. I highlighted the major ideas behind version control systems, or VCS, starting with how they help teams track changes, manage project history, and collaborate more effectively. The module also reinforced the key Git terminology. The module also clarified that Git and GitHub serve different but complementary purposes. Remember that Git manages version history locally, while GitHub provides a public or private cloud-based platform for collaboration, sharing, and contributing to projects. There are many ways to continue your learning journey. I encourage you to watch other videos in this course or search for your next favorite topic on Microsoft Learn at akms.com/learn. I would like to thank you for having been here with me for this first section. There's a lot more to talk through, so allow me to invite you to join me into the next module, where I will talk more about GitHub as the go-to development platform. See you back soon.